I will talk about relative velocity, and you will encounter problems like man crossing the river when river is flowing, and aircraft flying when there is a crosswind and things like these. So you will have some problems on relative velocities if you're taking a physics 101 201 course. Just to remember that all the problems in relative velocity pertaining to relative velocity can simply be solved using the simple vector addition formula. We already have said that the way vectors add up is AB plus BC equals AC, which is nothing but graphical. This is the graphical representation, and this is AB BC. What is AB? AB is the vector from A to B. What is BC? BC is the vector from B to C. And what is AC? A is the resultant of AB plus BC, which is vector from A to C. And so this is the only formula which will be used to solve any problem in relative velocity. And mathematically this is implemented if, let's say, vector AB, I'll suggest to understand the Cartesian coordinate system of expressing vectors. We already have talked about that earlier. Let's say AB has a Cartesian representation AX comma AY, and BC has a Cartesian representation BX comma BY. Then AC will have a Cartesian representation AX plus BX comma AY plus BY. This is all the framework we need to solve any problem in relative velocity. Let's solve a problem. Let's say we have a river flowing, and this is flowing down with a velocity of 4 meters per second. There is a swimmer here who wants to cross this river such that he lands on the bank just opposite to him, right? And the swimmer can swim at 5 meters per second. So the question is, so what are the vectors? First of all, velocity of water with respect to ground is 4 meters per second. As we have already talked about, that we always should have an axis system whenever we have a problem related with vectors. This is the x-axis, this is the y-axis. Now you can see that 4 meters per second is completely in the x direction. Similarly, as swimmer wants to swim such that with respect to ground he lands up on the opposite side of the bank, so we want V of swimmer with respect to ground in the y direction, which means we do not want any x component of VSG, right? Because if there is an x component of VSG, then this guy will not land just directly opposite, but will land somewhere here or here. And this is important. G, swimmer is swimming, the reference is with respect to ground, so he should land opposite, in the opposite direction with respect to the ground. So his velocity should also be like this with respect to the ground. Only then he will be able to land on the opposite bank. Okay, what else? Well, we know that velocity of swimmer with respect to water is 5. Now we do not know about this direction, because this guy has to swim in such a manner so that he lands on the opposite direction. Now if he starts, let's say, if you think that if he should start swimming in the just in the straight up direction, then you know that this stream is going to wash him down the stream, so he'll land somewhere here, which we do not want. We want him to land somewhere here. So this guy actually needs to start swimming something like this, and let's say the angle it makes with the x-axis, you can redraw the vectors here, is theta, right? Is theta. Is it clear? So we can draw the vectors here. This is VWG. So let's write down the equation. We want VSG equals VSW plus VWG, right? You see that the same as this expression. ABBC is AC. Similarly, SWWG is SG. Alright. So you see now the magnitude has been given to be 5, and we have assumed the angle to be theta. So we are assuming that swimmer should make an angle theta with the x-axis such that he lands up just on the directly opposite bank. So let's write down all the Cartesian coordinates of all the vectors. Well, VWG is 4, 0. The x component is 4, but there is no y component. VSW is 5. VSW is 5. Well, you see, we have defined SW, the velocity of swimmer with respect to water, in the polar coordinates. Magnitude has been given and the angle has been given, and we already have talked about how we can go from polar to Cartesian system, and we know that this is going to be V5 cos theta, comma 5 sin theta, right? Okay, so let's add VSW plus VWG, which is the right hand side of this equation. And if we do that, what do we get? We get 4 plus 5 cos theta, comma 5 sin theta, using this particular idea. And this is nothing but VSG, right? Now we already know that VSG should be in the y direction, completely in the y direction. So we expect this to be 0, because if this is not 0, the swimmer is not going to end up in the opposite bank, on the opposite bank. So we expect 4 plus 5 cos theta equals 0, and that gives us cos theta equals minus 4 divided by 5. Okay, now you can see theta, cos theta turns out to be a negative number. Well, it should turn out to be a negative number, because we know that cos theta, is negative if it's between 180 degrees, which is this whole complete angle, and 90 degrees. So you can find out the value here. Theta will be cos inverse 4/5 minus of. I do not want to calculate this number, but I think it will be between 90 and 180 degrees. Alright, so we were supposed to find this angle theta actually. In which direction should the swimmer swim so that he reaches the opposite bank? So once you have the angle, you will know what angle should he make with the x-axis so that he lands up in the on the opposite bank. You can see how beautiful math is. Cos theta turned out to be a negative number because the swimmer has to swim in this particular direction. Only then he will reach the opposite bank. Just a word of caution: cos theta can be negative for any angle between 180 and 270 also, but that is not going to be the right answer. If you take a cos inverse, you'll get many answers, but the right answer should be that the angle should be between 90 and 180 degrees. So we can solve any problems on kinematics using this particular idea. Okay.